Hello friends, welcome to this session of Learning R. In this session, we'll see how to analyze data from the scratch. In this session, we will start importing the data, then we'll explore the data, we'll try to understand the data, then we'll go for data summary table. We'll prepare data summary table using Gtsummary package, a TBL summary function, and data manipulation we are going to learn because that is required to make the data easy for further analysis. Then we will go for data visualization. In data visualization we understand patterns which are present in the data, and from those patterns we can create some questions or hypotheses, and those hypotheses will test also. And after that we have to make a report of our analysis done, and the script which are going to create here, we are converting that script to report using R Markdown's render function. Let's start our journey. And in data import, I will just import the file, and for that I will copy the file path. Here my file is present in this directory. That file is Mango file, and that is CSV data format. I will just click on this path and copy the address and bring that address here in the function setwd to set my working directory. And from now on my working directory will be rworks ci plot, and my data will be imported from this directory, and the work which I will do here will be saved in that working directory. I will run that line. To run a line, I have to take cursor on the code and then press Ctrl Enter. Keep pressing Ctrl and then click Enter. The line will run. Another way is also there. Click on the line and then click the Run button here, and the line will run. And here in the console you will see the code also, and below that code you will see the output of that code. Here no output is there, therefore it's not being seen. Now I want to see which files are there in my directory. List files is the function. Again Control Enter to run the line, and here you can see that Mango CSV is the file. This is my script file which we are working with, and this is Mango CSV is data file. I am copying that file. I'll bring that file here, and here df is the object where I will import that data. My data, imported data, will be saved in this object, and this object you will see here in the global environment. I will just remove the objects from this global environment, and the environment is ready. Now my new objects will be here. I'll just use the function read CSV because the file which I am going to import is read CSV. There are different functions to import different data formats, and here my data format is Mango CSV, therefore that CSV file I am going to use. And file name shall be in inverted quote. You have to remember that, and that extension shall also be there. If you forget that inverted quote, if you forget the extension, the file the code will not run. And code has been run, and the imported data got stored in this data file object df. Here that df object is there. You can click here to see the object. I will click here. You can see the object here. Okay. That Alfonso, Kesar, these 11 variables are there. 10 variables are numeric variables. These are different varieties of mangoes. These fields are there. In 2 fields those mangoes are planted. 10 varieties in farm 1 and the same 10 varieties in the farm 2. And when they fruited, their fruits were measured in grams, and these are the weights of the 25 fruits for each variety in grams. And we can see that in data exploration we'll see how to see the data, and we can see using the view function also the file will open as a spreadsheet here, and again the same information but without this data type information. All those 11 columns are visible, and all those 50 rows are visible. 25 rows are for farm 1 and 25 rows are for farm 2. I'll go to our script again, and there we can type in df and we'll run that. When we run that, the data will be shown in this console, and that actually is not advisable because large data floods the console, and this is how our console gets flooded, and we have to do much efforts to read the data. To avoid that, we can use the function head. head function actually shows first 6 data by default, first 6 rows of the data by default, and these first 6 rows are sufficient to know about which type of columns are there, variables are there. Alfonso, Kesar, these are numeric variables, and this variable field is the character variable. But from this we can't see that. To see that, we have to use the structure, that which type of variables are there, structure df. And now here we can see the similar one, just as we saw that in global environment, similar one, that 10 are integer variables and 1 is character variable, and their values, first few values are also shown there. Another is there, that is summary. Summary function is a generic function, and here we are applying that to object df. That df is a data frame. You will learn what data frames are when you start studying data structures in R. You have to know about the data types also. That numeric and character data type we have seen here. Other data type is logical, but you will have to learn that. Summary df, this summary is there. In the summary, we can see the minimum of the column, maximum of the column is there. First quantile, below that first quantile 25% observations are there. Third quantile, above that third quantile 75% remaining 25% observations are there, and between the first quantile and third quantile, that is called as IQR, 50% observations lie. And that spread of this, if spread of these quantiles, first quantile, second quantile, third quantile and fourth quantile, if those are symmetric, we say that the data is distributed symmetrically. And if there is a large variation between the distance between first quantile and difference between first quantile and third quantile, or third quantile and fourth quantile, we say that data is not symmetrically distributed. Median is actually the second quantile. Exact, say the data value which is exact at the middle of the data when we arrange the data ascendingly or descendingly, that is median. Mean is sum of all the observations divided by how many observations are there, number of observations or count of observations. Mean is also called as average, and that is sum of observations divided by the count of observations. And this is numeric summary, and we get that for numeric columns. But for character column, we just get counts. Okay. It's a class character, mode of that is character, and field, that length is 50 observations are there in that. Now we may require very comprehensive summary, and for that we will use the package, I am calling that package library Gtsummary, and this package is installed. Therefore, when I run this library Gtsummary line, we will not get any error here that package Gtsummary not found. Okay. If you have not installed that, you will get the error that package Gtsummary not found. When you get that error, it's that the package is not installed. Go to tools menu, click on install packages, and a dialog box will appear, and in that dialog box type name of the package, and the package will be shown as the drop down list. Select this required package, click on the install, package will get installed. I will not click install because I have installed the package already. Cancel. Then when you install the package, you have to run that line library Gtsummary. Okay. Now functions of Gtsummary are there in memory of my computer. The tbl summary is the function which gives me summary of the data in a HTML table. Okay. Here in this table, here we will see that summary, and that is quite well organized, well formatted table. You will see that df, just this is sufficient to give us this type of table, and this table shows these characteristics, means variables these are there. We can change the label characteristic also to variable names. Alfonso, Kesar, Dasheri, Langra, Banganpalli, Chausa, these are there. And then field, in field two groups are there, two levels are there, farm 1 and farm 2. Now these are numeric variables, therefore those are by default, those are summarized as median, and after that it is interquartile range. This is first quartile and this is third quartile. You can see from that summary, for Alfonso this is first quartile and this is the third quartile, that is shown here. Okay. And this is approximated without a decimal number. Suppose we don't want this, This is median. In the footnote also we can see that it is median, and IQR, followed by for character variable, that is count, followed by percentage. If you don't want this, you want that to be shown as mean. If you know that your data is continuous and median is not good measure of central tendency, you may want to use mean and standard deviation. Okay. For that, I will put here argument statistic, and in statistic is equal to, I have to select variable type, and all continuous variable I will play with, because I want to change that summary only, all continuous. This is a selector function, therefore this bracket is there, it's a function. And after that I will put this tilde symbol. It is for formula interface, and you will see this tilde symbol above the tab key on your keyboard, below the escape key on your keyboard. After that you will have to put inverted quote, because this will be there in the table. If you want that string in the table, you need to put the inverted quote. In the inverted quote, you are going to compute the statistics. For computed statistics, you will put this curly bracket, and in curly bracket my statistics is mean. Okay. I have prepared a special video also to explain how to use this Gtsummary package. You can go to my channel and find out it's very recent video. I may put that list in the description also. After that I will put comma. Comma is also not required, but we will put that comma, and again in bracket parenthesis I want my statistic, and curly bracket to get that statistic. In curly bracket I will put SD. Okay. Now you will see that this statistics get changed, and the footnote also changes automatically. I will run that, and now you can see that mean is there, followed by comma, after comma parenthesis is there, and below that mean SD, this is there. This is how to get summary table using Gtsummary package. This table can be saved as PDF, can be saved as Word, PNG, or any format which you want, which is allowed by the package also. Then another very good package is there. That package is called Psych. I will call that package library Psych, a very strong package for psychological data analysis or for many general purposes also. And here this package summarizes the data quite elegantly. And again, when you get that output table, you can convert that table to HTML format or other format also, using other utilities provided by the R programming. And I will run that, and no error is there. If you get error that package is not installed, then again go to tools, type name of the package, and select the package from the drop down list, click install, package will get installed. Now the function from package is describe. You can see this drop down list describe. This tool this facility is there in RStudio, that when you type first 3 alphabets, you will get the drop down list of the functions, and from that you can select your functions. In the curly bracket, name of the package is there. I will select this function, and in that I will put the name of my data, df. That is sufficient. You will get that. And this is the summary which I am getting here. This actually I shall get a very long table for that. I will run that again, so that a table will be there. Entire table is there. These variable names are there as row names. Whereas these are the variables. This n is there, number of observations for each variable. If missing observations there, those will also be shown here. Mean of all those 10 observations is there. For character variable also, mean is shown. You have to be careful that star is provided for that character variable. Then standard deviation is also there for those values. Median is also provided. Trimmed mean, will explain that in other videos. Mean absolute deviation is also there. Minimum, maximum, range, skew. Skew is for is a graph parameter of graph, whether that graph is towards left side of the plot or towards right side of the plot. Okay, that skewness is there. Kurtosis is there. Kurtosis is actually peakiness of the plot. Flat plots and peaky plots, those are kurtosis is the measure of that. Large spread in the data or small spread in the data. Standard error is also there. And this table you can again convert to your required format using cable extra or other packages provided. You will not see that in this. Now we are through with the summary. Many other packages are also there which give very elegant data reports, and here I have not explained that. I may prepare the videos, or I might have videos in my playlist. Now we are going towards the data manipulation. If you see here in the data, that data has weight observations of 10 mango varieties, weight observations in gram, and these are different mango varieties. These mango varieties are actually values of a variable called as variety. Alfonso is value of variable variety, Kesar is value of variable variety. Instead of being in a single variable, those are there as 10 different variables. That is messy data. That is called as untidy data. Now I will tidy that data. I will bring these observations, Alfonso, Kesar, Dasheri, in one column called as variety, and their corresponding readings in other column called as weight values. That's the tidy table. Again, I suggest you to learn more about the tidy data, and for that we are going to use library tidyr. And I will run that. And if you have not installed that tidyr, then again go to tools menu, install packages, type tidyr, the library will get installed. Tidyr library will get installed. If you want to install all the packages from the Tidyverse bundle, it's a very large package bundle for data analysis, data manipulation, and very popular also, and that's the reason for our programming being popular. You can install that bundle also, Tidyverse. I will not install the bundle now, and library tidyr is there. Okay. And I have run that library function, and from that library I will make an object called as dflong. My manipulated data will be stored in dflong, and my data is df. This is input data, and after input I put a pipe operator. This is the pipe operator. This pipe operator comes from this Tidyverse packages, and df, that data frame, will be piped in this pipe, will go through the pipe to the next function, and that next function is pivot, and that pivot longer is the function. And if you see yellow box appeared, it is to help you. Columns is the first argument, then names to, values to, these are required arguments for us. I will put the columns, and as you know that first 10 columns are numeric, therefore 1 to 10 columns, we want to collapse those in a one column. Okay. Names of those columns will go to a column, and as we are going to get a name for that, I am putting this inverted quote for that, because it's a name now, and then when we run this command, this name will become object. Later on, that inverted quote will not be required for most of the functions. Names to, that will be variety, varieties, bear with my spellings, and then values to, values will go to weight. Very easy to use function, very easy to use interface. I will run that, and now we will see how that dflong looks like. Run that dflong, and field is there. Farm 1, first 10 observations are shown, 490 observations are remaining. For 10 varieties, 50 each, 500 total observations are there. Farm 1, Alfonso, Kesar, and all those are shown, and weight values are shown there. That's the we have created from white table a long table, and this long table is very useful for further data analysis. Here I am preparing summary of that data manually, summary of data, and for that I will require, this is the object which I created, but before that I will have to call library dplyr, and if you have not installed that, please install before running this line. And you can install again through tools, install packages, and type in the name, and usual practice is there. Library dplyr, and for dplyr again the package dflong will be the input. I am getting that. Then pipe and group by. I want to group by these two variables, field and varieties. I am copying this from console, put that there. Now no inverted quote is required, as these objects are in the memory, and this group by is there. After the group by, I will put pipe again. This grouped data will be piped in to the next one function, that is the summarise, and in summarise I will put mean weight is equal to mean weight is equal to mean of weight. Now again I said that no inverted quote is required because these objects are in the memory. Then next is SD weight, and I will put that SD is equal to WEIGHT. Now standard deviation will be calculated and that will be shown as a table here, and we'll see how that DF summary looks like. I have selected that and I can run that directly to see how that summarization has taken place. Summarization has taken place quite good. Now we'll move to the data visualization, and in data visualization, as this is repeated data, we'll again go to the data, and this data, repeated data, we can see how those values are distributed. And for that df long only we will consider, because df long helps us. We don't have to put each variable name, that when we make that as a df long. If white table is there, this plotting becomes really difficult. And now again we will require one more package, and this package is again like tidyr and dplyr from the Tidyverse, ggplot2. And if you have not installed, go to tools and install ggplot2 before running this line and run the library. You don't have any error, means package is installed. Now ggplot is the function. I will run that, and when I run this function, I will not get anything here, just a blank canvas in the plots region. Blank canvas, because I have not specified the data and axis. Even when I specify the data, that df long, and run the line, it will not show anything. But data is there, and the function is waiting for us to provide required information, that which variables will be mapped to the different attributes of the plot. We will map this to attribute y-axis and x-axis. Two variables will map, and will map to color also. We can map to fill also, and for that mapping is done using the function AES. Okay. Inside AES, I will put the x variable, that will be my field. Field will be x variable. Now this time we'll go for the weight, mean weight. I want to show the mean weight only. Distribution I want to show. It's a univariate plot we are going to plot this time, histogram and density plot, and later on we'll make that bivariate. Okay. Now we'll run that. Now x-axis will get scaled here. Its mean weight not found. df long. No, only weight is there. In df long, mean weight is not there. That mean weight is there in the summary. Weight is there in df long. We'll run that, and you can see that here the x-axis got scaled from minimum to maximum, and even spaced ticks are made, and these grid lines also appeared. Major grid line, minor grid line. We have not specified y-axis, therefore these are not there. Y-axis here in this case will be specified by our statistic, and here I will put that as geometry. And that geometry, first I will plot the frequency plot, that is called as histogram, and this is sufficient command to get a plot. A nice plot is there. But still I want to see those different 10 different varieties. 10 different varieties are there. Therefore I will specify map the fill attribute, fill of the bar, to the varieties. Fill is equal to I'll bring the spelling, that varieties. I copy that. I do that to avoid the spelling mistake. If I do spelling mistake here, then it will show that object not found. I will run that, and now a very nice plot is there along with the legend. That legend appeared automatically, and we can control all these elements of the plot if we learn that ggplot. I have much large collection of the plot videos to teach how to plot data of how to get different plots, how to plot different data types also. And now I will just copy this code, bring that. Another thing we'll do here, we'll specify the color in this geom histogram. Now this color will not map to any variable, just color is equal to, and I'll put there gray 80 color, and we'll run that, and you can see this plot. Not much good plot to see distribution, to compare distribution, but still uh, just we are learning that. Now this histogram I will change to density. Same code, just the plot geometry will be changed, and you will see overlapping densities are there, density plots are there. This is kernel density plot, and the overlap is not much visible, therefore I am putting alpha there. Alpha is equal to, that is transparency, and when you go to 0, that transparency is almost full. Okay, I don't want that, I want that to 0.5, so that I can see the overlap and I can see the colors also. Okay. But still very little information can be obtained that Neelam is peakier, that distribution of Neelam is quite less, and distribution of this pink one, I think it's Rajapuri, it is quite large. Deviation is there, standard deviation is there, very great one. This is distributed one. Now we'll make this plot bivariate plot to create a other plot, because this distribution is not quite visible. Therefore here in the x axis I will put one variable called as field. I think that spelling is correct, FIELD, yeah, spelling is correct. And this geom density I will change with boxplot. Okay, this code is sufficient, but this alpha and color are not required, that alpha is quite less. Therefore I will remove these two, because default values are quite elegant here for boxplot, and this is the boxplot. Now you can see the boxplot is grouped for farm 1, because this is for field x-axis, and color is specified by varieties. You can see the legend also. This is a grouped boxplot for farm 1 and farm 2, we can see. Okay. Now this boxplot can be converted to a violin plot, because this boxplot actually doesn't show the data distribution, local density distribution, and for that we go for the geom density and run that. Not geom density, sorry, geom violin. I did the mistake, and that's why this error is there. And by practice you understand what error is there. Similar to boxplot, but instead of showing summary in boxplot, 5-point summary has been shown. This is actually the fourth quantile, this is third quantile, median and second quantile, this is first quantile, and this is the 0th value. Okay. When values are beyond these whiskers, this is called as whisker, and this part is called as box. Therefore this plot is also called as box whisker plot. Beyond these there are outliers. These black points are outliers, and these outliers, a specific formula is there by which we decide what these outliers are. And these outliers, we have to be careful, that can be error in the data input also, or sometimes those can be very important information also. Many times we can combine these box plots and violin plots also to show the specific information. I'll just copy this and put that here, and we'll run that. And we may have to play with transparency to get that, because boxes are overlapping. This is layer wise arrangement. Lower layer is violin as we have coded, and upper layer is box plot, and this box plot is masking violin. Therefore to avoid that, I will increase transparency of box plot, alpha is equal to 0.3, and we'll run that. Now we can see that violins are quite visible also there. Okay. Not much elegant one. We can overlay points also on that, and many other plots are there to show the distribution, and you can see those different plots in one of my videos where I explain how to show the data distribution. And we'll stop here for this data visualization session of this tutorial. Now we'll go to hypothesis testing. If you see there, you can see in farm 1 the weight is quite low, and in farm 2 weights is little high, and there is differences in weight due to varieties also. Okay. For that, initially we'll go for to find out whether this farm 1 and farm 2 is there any real difference between their weights. Therefore we'll prepare a null hypothesis. Null hypothesis is designed in negative terms. we want to see say that here difference is there, and we'll say that null hypothesis, there is no difference. Okay, very crude null hypothesis it is, because the scope of this session is not to teach null hypothesis, but we say that there is no difference. And here we'll decide on the alpha. Alpha is equal will be 0.05. That alpha is called as the significance level, how much error we can allow, how much false positive error we can allow. Even if difference is there, sometimes we may say that there is no difference. Okay, and that error allowed is 0.05, means 5% of the times will allow the error, but 95% of the time we shall see the actual difference there. Okay. Now I will just this error is actually false positive. If difference was not there, difference were not there, this value shows is the probability of doing that mistake of saying that there is difference even when difference is not there. Okay. That null hypothesis thing you will have to learn more. Many times I get trapped in that binary whether to accept or not, and that also we'll see little later. Just accept here that there is no difference, and that significance level we have taken as 0.05, that alpha is 0.05. And here another alternative hypothesis is there is difference. I'll just okay, there is difference, and that is statistically significant difference, and that difference in means, the test which we are applying is to find out the difference in means. Okay. That test is t-test, t.test, and here is the code for that. I will just save that object as tt, test object as tt, and put the code t.test in the bracket. We have to use the formula interface. That weight is dependent, again tilde symbol, field, F-I-E-L-D, and the data is coming from df long, okay, and we'll run that. Now the test has been calculated. We'll see what is there in the test tt, and we'll run that. And this is, it is Welch 2 sample t-test. It is very robust to the distribution. There are two types of hypothesis tests, parametric and non-parametric. In parametric tests, we know the distribution, and we compare the distributions of the two or more data which we want to compare. But this t-test is very robust to that, even when no normal distribution is there, the test gives us good results. Other alternative is Mann-Whitney test, but will not go towards that. This Welch sample t-test will learn. Now this is the output of that, and t statistics is -8, and degree of freedom is 430. That is very high degree of freedom, and at that freedom, when we have degree of freedom 30, degree of freedom is actually dependent on the sample size, how many observations are there in each group. That if degree of freedom is above 30, we accept that that critical value of t is 2. If you go beyond 2, here it is -8, means very less than -2. Okay, absolute value of 2 we require, -2 or 2. When it is way beyond that -2, we say that there is statistically significant difference in the mean of those two groups, this t. We can interpret using the p-value also. P-value is near 0, almost 0, and p-value very naively, very grossly, we say that it is the probability of getting the data similar to what we got, or getting the difference 0. Okay, this is the probability, getting that different hypothesized difference 0. But that probability here is almost 0. Therefore, we say that difference is not 0. The difference is other than 0, or there is actually proper difference, and these two groups are statistically significantly different from each other. There is difference in weight of field 1 and field mangoes from field 1 and mangoes from field 2. Okay, farm 1 and farm 2, there is difference. These values are provided here. Another is 95% confidence interval, because we are playing with 0.05% alpha, that is default. Here we say that at that alpha, this is the -72 to -46 is the difference. Okay. That field 1 mangoes are quite weight of these mangoes is less as compared to farm 2 mangoes. Okay. Therefore, that minus difference is there. But when we see here that 0 is not there in that, in this 95% region, 0 is not there. Therefore, we have to say that if 0 is not there in 95%, we are sure that almost 95% of the time we will have difference in the means. When our hypothesized difference, most of the time that is 0, if that difference is not there in the confidence interval, we reject the null hypothesis and we accept the alternative hypothesis. And under the conditions when 0 were there in this 95% confidence interval, when t value is less than 2 and when p value is more than 0.05, we accept the null hypothesis. We say that there is no difference. Okay. My one video is also there to explain how to interpret t-tests and how to implement the t-tests also. You can go through that to understand more. Another test is there to study more groups. Here two variables are actually affecting the mango weight. Those are field and variety. Okay. Initially, we will study effect of one variable variety only, and for that I will create a object called as mod Anova. I will apply the Anova test, that is called as analysis of variance. It is not actually analysis of variance, that is comparison of means only. This is misnomer. And AOV, my output will go to this object mod Anova. AOV is analysis of variance function. It requires formula. Then same formula will go for the weight, tilde symbol, and variety is the variable varieties. And therefore, I prefer copying, and the data is coming from df long, and we'll run that. The mod Anova is calculated. We'll see summary of mod Anova, and we'll run that, and we see here that output is there, sum of squares is there, mean sum of square is there, f value is there. Okay, we'll explain that when we go for the Anova video. I have actually have that Anova video in my YouTube channel. This is the p value. P value is quite less, almost 0. We are at level of significance 0. We say that there is difference because of varieties, difference in weight because of varieties. Now, if we want to see the pairwise difference between whether the Alfonso and Rajapuri are different, whether the Alfonso and Dashera are different, we have to use the Tukey HSD. Tukey HSD test. Tukey is honest significant difference test on this object, mod Anova object. Control C, save there, and run that. A pairwise difference will be shown, and you can probe this to find out whether there is difference in the weights of these varieties or not. In Banganpalli Alfonso, no difference in weight is there, almost similar weight is there. Chausa Alfonso, similar weight is there. I don't know whether the weight is similar in these mangoes. This is simulated data. Dasheri Alfonso also no difference is there. Then Himsagar Alfonso also no difference is there. But Kesar Alfonso, there is statistically significant difference in Kesar Alfonso, and difference is negative. Kesar is quite less in weight as compared to Alfonso. That is not actually true. Kesar and Alfonso are almost similar in weight, but that is shown here, and many a times Kesar is quite larger than the Alfonso also in my experience, and for each pair you can probe that. Another version of that Anova, I will just copy this code here and put that here, mod Anova 2. I make that, and along with the varieties I will probe for the variable field also, and we'll run that. Now this is two-way Anova. This is two-way Anova. I will run that, and summary. Variety is also significant and field is also significant on the weight, have significant effect on the weight. Okay. Degrees of freedom is quite large, therefore we have to accept this result. These results are reliable, and that significant codes are also there. Both the variables are significant at the alpha 0. Highly significant these are. If you want to interpret these variables without interpreting yourself or automate that interpret, you have to use the library report for that. And this is very useful library, because this library avoids that confusion whether to accept or reject the null hypothesis. Okay, we manually can do, but here that will be done by using a algorithm for that. Report library provides a function report for that. If you are not installed, you can you have to install this report package using these tools and install packages. Report is the function, and in that I will first give it the t-test results, and we'll run that. You'll see a text output here, and that text output, that I will not read all that. The Welch to sample t-test is implemented to study effect on weight on the difference in the fields, that the effect is negative, statistically significant and large, and that is all the statistic is provided. Another package is also there, that is called as library Weber, and that also gives us a very good function to learn more about this. That is plot. A plot method is available for these TT objects, that test objects. I will show you what class that TT object is. The TT object is class of htTest, and this Weber package provides a function to plot these htTest objects. I'll put that TT here, we'll run that, and you can see the plot here. Okay. A quite good plot. The overlap is there just because of the size, and now here no overlap is there. P value is less than 0.05, and that t statistic, if you see t statistic is there at the extreme left, and this is not in this acceptance region. This white region is acceptance region. If the statistics were there in this acceptance region, we have to accept that null hypothesis is true, there is no difference. But that t statistics is beyond that acceptance region, is there in this rejection region. Therefore, we have to say that we can't accept the null hypothesis, and we have to say that alternative hypothesis is true, there is statistically significant difference. Okay. Same report, this report can be applied to Anova also. Report Anova model, that mod Anova 2 I will put, and I will run that. You can see the report. Yeah. And you can go through that report to understand more, to interpret more. And unfortunately for Anova, that plot method is not available, because Anova object is not test object. This concept also you have to learn if you want to be expert in R programming. Okay. This is not test object, that is AOV and LM object. You can find out Google, you can search on Google or net to find out what function can be used to plot these Anova models or LM model. That when we run plot, we don't get this type of plot there, Anova model, and I will not explain, I will just show you the output, how the object gets plotted. Many different plots you will get. Enter here again, the different plots are there, and these plots are diagnostic plots for model Anova, and similar plots you get for LM also. This is LM object. Okay. And now I will show you how to convert this entire analysis into report. Still more is there to analysis. This is just cursory analysis or very superficial analysis. Many other things can also be done with this data. I will not show you that, but I will just show you how to make that into report. I will save this file, and I will first select the entire file to confirm that the code is running. And when I select that, I will click on Control Enter or click on Run button. The functions will run, and it will take some time to run all these functions. My data is not that big, therefore it will not take that much time. And again I have to click that, all that is there. The code is running, entire code is running, no error is there. Therefore I will put that package R markdown here. The function is coming from R markdown, therefore these 2 colons are there after the name of that function, because I am not working in my script. This is my script window. I am not working in the script, I am working in console. because this code I don't want to run in the script. I want to run that from the console. Render is the function, and in bracket of the render I'll put the file name. That file name is data-analysis.r, data-analysis.r, and the file name shall be in inverted quote. Okay. And run that. I will get an HTML file. Okay, one spelling mistake is there, that two A's are there instead of one A. I will run that again, and now the file is running. It is getting compiled. It will be initially compiled to spin.rmd, and then later on that rmd file will be converted to markdown, and then this markdown will be converted to HTML format. You can convert that to PDF, you can convert that to Word. We'll see the PDF HTML output first. This is the output, data analysis, and you can see the code also there. This is the code, output of the code, output. We can put our text also here. I have put this text, data import, data exploration and all that. You can put that as title, and all that formatting can be done. Okay. All the plots are also there, all the Anova output is also there, and everything is also there. Okay, I will share this output also with you. If you want to have the PDF output, I will just try, and if my system is configured to get the PDF output, then I will get the PDF output, PDF_ document, and will run that. Okay, that RMD, same thing is going on. It is first converting to RMD, then later on it will convert that to MD, and that MD will be knitted to a PDF. That PDF compilation is going on, and if that compilation succeeds, if my LaTeX is required for that, if my LaTeX installation is proper on my system, that PDF output will be there. It is taking some time, and you can convert that to Word file also. If Word is installed on your system, you can convert that to that PPT format also. If you are using the PowerPoint on your system, that PDF compilation is taking little time. Because I think my LaTeX installation is putting some hurdles. No, PDF is not created. I have to correct my LaTeX installation to get the PDF properly compiled. Yeah. And we'll stop here for that, but I assure you that we can get, and one of my video is also there, how to convert your script into different output, and that output we get here. I stop here for this video. You can go through other videos on my channel, YouTube channel, to learn more about R programming. And thanks for watching this video. If you have liked this video, please click the like button. Share this video with your friends on your social media. Also, you can share my videos to give them more. If you like those, you can do that. You can hit the like button. Please click the bell icon also if you want to get notifications of my new videos. And if you are not subscribed to my channel yet, please subscribe to my channel. Thanks for watching.